syllogism is an argument with 3 lines, the first 2 being true and the third line is supposed to be the logical conclusion from the first 2 lines. For example, if I had wings like an eagle, I could fly. I have got wings like an eagle, therefore I can fly. How do we write this in the language of logic? If, then, okay, so this is going to be if I had wings like an eagle, and you could imagine then I could fly. So that is an implication statement. So we write that P implies Q. The second line here, I have got wings like an eagle. It's the P part from this first one. And our conclusion, so our conclusion is under the line. Let's sort that out a bit too quick. So our premise is on the top and our conclusion is underneath. And the way I think about it is you're always going to have an and statement. We want this to be true and this to be true for this to be true. So let's have a look at the truth table. So we've got our we've got our P and our Q. And the first thing we're going to look at this time is the implication. Remember, true, friends forever, T, F, F, everything else is true. And we want P as well. So I've had to change that because I made an error, so that's P. So let's just rewrite out our P. So we want the answer to this, we've got the implication and P to be true. With an and statement, remember, it's and. We need true and a true for it to remain true. So let's change my colour. Let's go to so here we go. Our conjunction there is true because we've got a true and a true. That's going to be false. That's going to be false because we've got true, false, and we've got true, false. So that's going to be false as well. So we've now got our answer to this first bit here, and we want to use this with the implication of Q. Let's write out our Q. Write out our Q. Q down here, true, false, true, false. And so we're going to use this column with the implication of Q. So this column and Q, so the implication, true, friends forever. True, friends, no, true, friends, no, true, friends, no, true, friends. There's no true friends, which will give us a false, so it's all going to be true. That is a tautology as well. Let's change this argument slightly. If I had wings like an eagle, I could fly. I can fly, therefore I have wings like an eagle. So, if I had wings like an eagle, that's going to be our proposition P, and I could fly, it's going to be our proposition Q. So, if P, then Q is going to be our first line here, and our second line of our premise is going to be Q, I can fly. And we want to combine them together. We want this and see if our conclusion of P, I have wings, is a valid argument. Let's have a look. So, let's first of all P implication Q, true, friends forever, is just there. Everything else is true. Our Q, we already know, true, false. True, false, and we want to use the conjunction, which is our and, so we need to have a true value here and here for our answer to be true. So let's true, so that's true. We've got a true here, so that's true. Everything else is false. And finally, we want to say, right, we've got our answer, if you like, to the left-hand side. Does that imply P? Finally, we know P. Excuse me. We know P, we can just copy and repeat that. And now we're looking at the answer to this side here, so this column. Should be false. Not very clear, it depends. We we're looking for, does this imply this? True, friends forever. True, friends. So that's going to be a false. Everything else is going to be true. Okay, that is not a tautology, so this argument is not valid. Okay, so now we're going to look at an argument with three propositions. And this type of example means that we need to use the logical reasoning called the chain rule. We have got three propositions this time, P, Q and R. And we are going to say that the argument is that P implies Q, Q implies R, and therefore P must imply R. And it's quite easy, it's quite nice to think of it as steps to solving an equation. Because if our proposition P, 4x plus 6 equals 26, we know that the proposition Q must also hold because 4x must therefore equal 20. And we also know straight up that R must also hold because x must equal 5. So we're going to go, if P implies Q and Q implies R, then P must imply R. Let's write that using the language of logic. Well, if our first statement implies our second statement, and our second statement implies our third statement, then our first statement must imply our third. And remember, when we've got two lines of the premise, we want this and this, so they're going to be joined with a conjunction. So the logical form is our first premise, P implies Q, and, because we want them both, our second premise will finally imply, so we'll give the conclusion that P implies R. Now the truth table for this is starting to get a bit big, but again, if we just take it step by step, we shouldn't have any difficulty. Right. So remember, when we've got three propositions, we need to double up each row of our truth table for our P and Q propositions to allow for our true-false with our R. And let's have a look. So let's see, we want to do P implies Q. The implication is true, friends forever. So just looking at P and Q, true, friends. So it's that 1, 2, 3rd and 4th column down, which will then true, friends will produce our false. Here we go, and that's okay. Everything else in that column will be true. We also need to work out our implication of Q implies R. Remember implication, true, friends, so we need a true in Q and a F in false in R, and that will give us a false here. So let's have a look. Apologise that we have to flick up and down. Q and R this time. True, friends, so that's second row, and the 6th row of TF, so it will be finished with an F. There are second and 6th, so everything else is true. And we want both this and this to be true. So we need a true in both columns for our conjunction to hold true. True, true, great. True. Anywhere else where there's a true, true? Yeah, true there, true, true there, and true, true there. Everything else has got to be false. Okay, so this is the answer to our first part here. Now, we're going to look at the implication, whether this implies this will give us a true as well. So let's just fill in our P implies R. We want true, false to give us our false. So P and R. So we're now looking at this one, P and R. We want true, false. Here, here, so it's 2 and 4. So it's the 2nd and the 4th row will give us a false. Second and the fourth row will give us a false. Everything else is true. So the final thing that we need to do is to see, using this column, the result of this column, implication, the result of this column. Let's see if I can get a different colour. Let's have a look. Implication, again, true, friends forever. So we need a true, a false, will give us a false. So let's have a look. True, no, we're looking for true, false. No. Okay, so if we have, there are no true falses, that will give us a false, so everything else must be true. Great, so what do we have? We've got a tautology. Everything is true in that final column, so that means the argument is logically valid. And if you can do that, you're going to be okay.